Welcome to part 6, your final installment of your outline review for your midterm examination. Your sheet should begin with number 21, events of contraction. The events of contraction leading to sarcomere overlap and shortening starts with a nerve impulse. So this was done previously. So 1, nerve impulse. The nerve impulse leads to calcium release. This is important. This is the first event in the muscle cell that occurs that begins the cascade that leads to shortening of the muscle. Calcium binds to and causes the removal of the blockers. So calcium removes blockers, of which that was troponin and tropomyosin. The removal of the blockers allows myosin to bind to actin. Remember, actin was represented as an olive with a hole, and once that opens up, the head of the myosin gets in there. And then we get ratcheting. So let's see, the myosin head ratchets. I guess we'll make it a 6. So as it does that, the thin and thick filament overlap to a greater degree. So this overlap is a key action that occurs that you need to understand. Again, remember, there's a minimal overlap between the thick and thin filament when the muscle is relaxed, and that overlap increases gradually as the muscle shortens, leading to shortening. This here just reiterates that sarcomere structure and changes. Again, the idea is the thin filament overlaps somewhat. Let's see if I can do this. I'm wasting to the whoa, that's much thicker than I wanted it to be. The thin filament and thick filament overlap slightly. When the muscle is in a relaxed state. When the muscle is in a contracted state, that overlap is much greater. Actually, much greater. I want that H zone to disappear. So I apologize. All right, I don't know if I did a good job of that, but the idea between the relaxed and contracted state is the difference in the overlap. In the relaxed state, the overlap is minimal. Here, it's much greater in the contracted state. Aerobic training leads to changes having to do with oxygen. This is the marathon runner. So this includes increase in capillaries or blood vessels. This includes increased mitochondria to process that oxygen along with food. Anaerobic training is without oxygen. This is short distance burst training. This is the sprinter. who develops large muscles from tearing his filaments, and as they fill in and regrow in, he's got more of them. He stuffs his stocking filled with more toys. Recall that the problem with this type of training is it leads to fatigue in the muscles due to lactic acid buildup. But again, Hussein doesn't care if he gets tired because he's done after 8 seconds. On your sheet, you have 24 synergists and antagonists. I encourage you to look. There is a post, especially period 5 and 7, where I was absent for that lecture. There's a post on Google Classroom, and that is now linked to Moodle as well under midterm information. The idea is not difficult. Synergists work together. So a good example of synergists would be the quadriceps muscles. They act as a set to perform the same action, which is to extend the lower leg. The vastus lateralis, the vastus medialis, and the rectus femoris. These 3 muscles, we would say, are synergists. So I'm going to do this, synergists. These are synergists to each other. They all perform the same action on the same part of the body. Whereas antagonists work in opposition. The biceps and the triceps would be the easy example of antagonists. Let me put that over here. Biceps brachii, that's an A, C-H-I, and the triceps brachii. If I want to think about the antagonists to the quadriceps muscles, those would be on the back of the leg. The muscles that act to flex your lower leg, if you curl up your knee, and that's the hamstring muscles, which are your semitendinosus, and your biceps femoris. So I'm going to outline it this way. So if I want to look at examples of antagonists, I can say the biceps are antagonists to the triceps, and I could say the quadriceps are antagonists to the hamstrings. The other thing to note here, and again with these 2 muscle groups, it's a good example. These antagonists are often on the opposite parts of the body. So for example, your arm flexors are on the anterior body, your leg flexors, these guys here, are on the back of the posterior surface of your leg. The arm extensors are on the back of the body, whereas the leg extensors, these big quads here, are on the front of the body. The last note you have here for 25, it says general review. It says the muscles. So your human muscle diagram, that will be, I've decided, on your exam. That exact diagram, you will list the muscles exactly as found on the sheet gone over in class several times. And these, you will spell the names correctly, and you are also responsible for the actions, flexion or extension, abduction or adduction, for the majority of them. I will not ask you all of them, but for the main ones, I will. Good luck, everybody.